All right, so what I would actually call the central angle theorem is slightly different than what they did, which would then deal, in all the stuff you've been doing, you haven't really worked with what is actually the length of the arc. But you could measure an arc length as a number of degrees as well. And so if I have a picture like this, if that angle is making a quarter of the circle, it's 90 degrees, right? But that would also mean that this arc up here is like a 90-degree arc. And so a central angle, if this is 90 degrees, then the arc that it makes is a quarter of the whole arc, which is 360, like the circumference. Then the arc could be called 90 degrees, and that would be the same. Well, then the idea is if you have an inscribed angle, that's any angle on the circle. So this angle down here, this is called an inscribed angle. That goes back to like an inscribed triangle versus a circumscribed something. So the circle is circumscribing this green angle, or green triangle really, if I just completed the triangle. Okay, that triangle is inscribed in the circle because all the vertices are on the circle. Well, that angle then is always half the arc that it makes. So if that arc is 90, then this angle down here is half of the arc length, half of 90. Well, in your Education Perfect, it just said, well, it's half the central angle, and so if the central angle is 90, then so is that arc. Then that arc is half. But this would go for any arc. So this one is 45, and this one is 45. Anything that makes that same arc, all these circumscribed angles are making the same arc. They're all 45, half the central angle. Good question then could go the other way. What if all I knew was the 45? Well, then I would know that the middle angle is double it. Go the other way. So then another relatively simple problem would just be if I had a picture like this and I knew something about this angle, let's say it's 30 degrees, and then I could ask you to find any other angle. Well, if it's making that same arc again, I could just say, what is x? You know right away, oh, it's 30 degrees. Easy peasy. Thank you for my free points. And again, if I then drew it somewhere else, where it's in the center, and it made this, then I know it's 60 degrees. Because it'd have to be double, because this one is in the center. And the inscribed angle is always half the center angle, which means the central angle, is double the inscribed. Then they called it Thales' theorem and did a throwback to way back. But the idea here is if I have an actual half a circle, if I were to draw an angle, any angle that meets these two, if I were to actually go down and make this, that has to then be a right angle because it has to be half the central angle. Well, the central angle that makes this is 180, so half of that would always be 90, no matter where you draw it. Even if you drew it here, that's 90. And so there's some questions related to that. Yep. Okay, so in a picture like this, if I knew like this was 20 degrees, I could then find this bigger x up here or something, ignoring that other one, because I have a 20, 90, and x. But it won't label that as a right angle, but you know it's a right angle because it makes half the circle, a whole diameter. Okay, another one then, you might have something like this, where you just have to, so right away, whenever you have this, I don't know what we're finding, but I do know that this angle and this angle are making the same arc. They're both half of that arc, but they're the same as each other. Or maybe it's asking me questions going the other way. These two angles are both making this arc, and so they're half that. And so there's any number of ways we could find this. It could just say, this is 20. Or, well, that looks like 26. So that's 20. Oh, so this is 26. But what it might have is say that's 26, but what is this one? Why? well, then I'd right away, I would put, okay, so this is 26, like I just established, but I need something else. Well, then it might say like, oh, and then this is, 50. Oh, so this is 50. So y is 180 minus those two, something like that. Or it might give you that this is 130, which it clearly isn't. But then you could get that 50, which could give you the other 50. And then you do the add up to 180. That was drawn terribly as far as scale is concerned. But so, and then in a picture like this, it's the same type of problem. I just added a couple extra lines to distract you. But again, in a picture like this, all kinds of angles that make the same arcs are congruent to each other. It doesn't matter how many extra lines they drew or what they label. So they could label all sorts of random stuff on here. We could say this is 30. Maybe one of these is, what does this look like? This looks like 85. And then it could ask me for something that looks entirely unrelated to all of this. It could ask me something like this over here. What is this angle? X. But the idea here is x is the same as what? Well, x is making this arc over here. So x is, oh, so this is also x. And if this is 30 here, then this would be 60, because it's double it. Well, this would be 30. So maybe that would be helpful. If this is 85, then these are both 95. And this is 85. And then eventually, oh, so I didn't even need the arcs at all if that was x. But if I was trying to find this one, then I would have needed to know those arcs. And that kind of thing. So just you start labeling anything that's the same. Other things I didn't label yet. What makes this arc? The blue angles, okay? So that would be like this angle down here. So this one is congruent to this one up here. So if one of those is labeled as x, I could find the other one instead. Whatever's going to get me there. And then one more, little bit trickier one would be one cool one like this. If I wanted to find say this angle down here is x, I would know that it's half of this angle. Here. Be half of that. So that would be easy. If I knew that was 40, then x would be 20. But a tricky thing they did, and I like this a lot, is what if instead of that, I knew, say, this angle up here was, I don't know, was that angle look like 30? Let's say that angle's 30. I actually could find x from that because this, and this is going to be what we're going to do next week, these are both radii. So these are congruent, so ITT would say these are congruent. So this is 30, and if those are both 30, that adds up to 60, then this must be 90, which I don't like that because that's not 90. So let's say those are both 35. 35, that's 70. 180 minus 70, so now this is 110? What? Did I do that wrong? 110? Instead of 120? None of that seems, whatever. Those clearly aren't 35, those must be like 50. But whatever, let's just pretend that's 110, and now I can get so this is 55. But that has to do with the idea that anytime you have a central angle, it's always isosceles too, because the two sides of a central angle are radii, which are always congruent. And that should help you. Okay, you should now ace this quiz type thing, no problem. And hopefully, if you went back now, I bet you could do that whole other assignment. There were some other tricky ones in there, but this is the basic idea of what we're doing with angles inside of circles.